In this final clip on reaction types, we'll look at the fourth class of reaction, insertion-elimination reactions. They're a bit of the oddballs, but some insertion-elimination reactions are very important in organic chemistry. They're super important in organic chemistry. And we're really going to look at just the most important of all of them, which is what happens to carbonic acid. So first, do you guys know where carbonic acid is most present in American daily life? Put it in chat where you see it. Carbonic acid is in what stuff that we drink? It's in soda, and you have carbonic acid in the soda. And when you open the soda, the carbonic acid eliminates CO2. So it turns into water plus CO2 gas, which are the bubbles. And that's an example of elimination. The reverse reaction also occurs, which is the insertion. If you've got CO2 gas and you put it in water, it goes to H2CO3 carbonic acid. And now we're getting into the half of the reaction, which is much more serious than soda, because what is there nowadays in the earth, in the atmosphere, much more than we've ever had previously? What molecule is in the air? And the answer is there's just tons of CO2. The CO2 level is the highest that it's ever been. And where is there a lot of water? In the ocean. And so there's a lot of CO2 in the air now. There's a lot of water, which means that our oceans are making H2CO3, which means that the ocean is becoming more acidic. And this is one of the great disasters of the modern world. I hope some of you, because many of you will go on to different areas of science, will help solve this problem. But here is a very sad picture of what happens because the ocean is becoming more acidic. There are life forms that can't take more acidic water, and so the coral in the Great Barrier or off Australia, the coral in American Samoa, it's just dying, and there's all kinds of fauna that lives off the coral, and they've got to be dying too. So here's a very important insertion and elimination reaction in that's related to climate change. Okay. This is just a list of insertion and elimination reactions that I found looking through your textbook, chapter 10. And I would have this list handy for you for the final, just in case one of them shows up. But I don't think you need to memorize this list, but you should read it and say it aloud probably a couple times. Okay, where are we left off? You're going to want to figure out what's going on in reactions. And there are 4 types of reactions, and you should do it in an orderly way. You should do it in the order of importance. First, you should look if the reaction is redox. And remember, redox reactions are the most energy producing, and you're looking for electronegative atoms that get reduced and electropositive atoms that get oxidized. And remember also that at high temperature, the normal trends can be reversed, as you'll learn in 2080. Second, you're going to, after you've finished looking if there's any redox in reaction, if you find redox, you're done. You probably can figure out what's going on. You should see if there's an acid or a base. Look for strong acids and strong bases. They're also pretty energetic. And remember that in acid-base reactions, favorable reactions, strong acids go to weak acids, strong bases go to weak bases. That's the criteria. Precipitation dissolution reactions are memorizing those 6 rules and figuring out how to do deductions from them. The actual rules are not energy based. They're not based on all that stuff we've learned about electron energies. It's out of scope for 2070. You just have to memorize the rules. And finally, the insertion elimination reactions. There are important ones, so we should know about them. But again, it's not really energy based. The reasons for them are out of scope for 2070. And definitely know that CO2H2O reaction. And there's a little list that I gave you. Memorize a couple if you want to. But they're certainly less important than number 3. But you definitely will want that list handy for you for the final. So that completes our presentation of the theory of reaction types. You can pretty much use this to look at a lot of reactions now and say, oh yeah, I think that reaction should occur, and I see no reason for that reaction to occur. So it's been very quick, but it's going to give you a firm basis by which to understand a lot of other chemistry, which you will see not just in chemistry courses, but also in related fields. Okay. So that completes the presentation, and we really only have one more lecture to go. And in that last lecture, we'll talk about gases, and we'll use it as a platform to review proportionality theory. Okay, bye.